Next topic, Taylor and Maclaurin series. Okay, the Taylor series of a function f of z, the complex analog of the real Taylor series, that is f of z equal to sigma n equal to 1 to infinity a n z minus z naught all power n, where a n is 1 by n factorial nth derivative of f at z naught. That is what we done in real calculus. The same procedure what we will do here. So f of z is sigma n equal to 1 to infinity. This is Taylor series f and the derivative of z naught in factorial into z minus z naught all power n, which is equal to, this can be written as f of z naught plus f dash of z naught by 1 factorial into z minus z naught plus f double dash of z naught divided by 2 factorial into z minus z naught all square plus etc. So this series is called a Taylor series. Now, Maclaurin series is a Taylor series when z naught is equal to 0. So if you replace z naught by 0, we will get Maclaurin series. So f of z of Maclaurin series is f of sigma n equal to 1 to infinity, sorry, 0 to infinity, 0 to infinity, f nth derivative of at 0 by n factorial into z raised to n, that is equal to f of 0 plus f dash of 0 by 1 factorial into z plus f double dash of 0 divided by 2 factorial into z z square plus etc. So a Taylor series at center z naught is equal to 0 is called a Maclaurin series. So one of the important property is let f of z be analytic in a domain and let z equal to z naught be any point in the domain. Suppose this is complex plane, this is our domain. If z naught is a point and f of z is analytic, f of z is analytic at z naught, then there is precisely one Taylor series with the center z naught that represent f of z. So if you have any series representation, Taylor series representation of f at z naught, that must be unique. There is one and only one Taylor series expansion. Now we will do some problems. First, find Maclaurin series expansion of e raised to z. So we know that Maclaurin series of f of z is f of z is equal to sigma n equal to 0 to infinity f nth derivative at 0 divided by n factorial into z raised to n. So that is equal to f of 0 plus f dash of 0 by 1 factorial z plus f double dash of 0 by 2 factorial z square plus etc. So here given f of z is equal to e raised to z, then what is f of 0? Then what is corresponding f of 0 is equal to e raised to 0, 1. What is f dash of z? F dash of z is derivative of e raised to z, again e raised to z, and f dash of 0 is equal to again e raised to 0, 1. What is f double dash of z? This is again e raised to z, and f double dash of 0 is equal to again 1. And similarly, if you if we continue like this, we will get nth derivative of z e raised to z is e raised to z of 0 is equal to 1. Therefore, Maclaurin series of f of z is equal to e raised to z is equal to, we replace f of 0 by this. So 1 plus f dash of 0 is 1 by 1 factorial z plus f double dash of 0 is 1 by 2 factorial z square plus etc. So this is 1 plus z square by 2 factorial plus etc. So this is the Maclaurin series of e raised to z. Now, second question, find Maclaurin series of 1 by 1 minus z. So f of z is equal to 1 by 1 minus z, where z equal to 1, it is not defined. So any point other than z equal to 1. So we will, it is analytic, so that we can find the Maclaurin series. So first what we want to do, we want to find out f of 0. This is 1. Now you find out f dash of z. Derivative of this is equal to 1 by minus 1 by 1 minus z all square into derivative of minus z is, so this is equal to f dash of 0 is equal to again 1. Okay. So now you will find out what is f double dash of z. This is 1 by, so minus 2 by 1 minus z all cube into minus 1. So f double dash of 0 is equal to 2. And f triple dash of z is equal to, here already 2 is there. Then we will get 2 into 3 divided by z minus 1 raised. So this is actually 2 is 2 factorial. And double triple dash of c is 3 factorial. If you continue like this, you will get f nth derivative of z is n factorial divided by 1 minus z all raised to n plus 1. So this is f nth derivative of 0 is n factorial. Okay, so how to find out we will check. So I will move this up. Okay, and so what is Maclaurin series? Maclaurin series of f of z is equal to 1 by 1 minus z is equal to, what is f of 0? 1 plus f dash of 0 is 1. So 1 by 1 factorial into z plus next 2 factorial divided by 2 factorial into z square plus 3 factorial divided by 3 factorial into z cube plus etc. So this is equal to 1 plus z square plus z cube plus etc. So 1 by 1 minus z, whose Maclaurin series is 1 plus z square plus etc. Now we know that now next question, find the Maclaurin series of e raised to z square. So here f of z is equal to e raised to z square. And we know that by Taylor's theorem, that is, the Maclaurin series or Taylor series expansion is unique. So what we will do is, we already know that Maclaurin series expansion of e raised to z is equal to 1 plus z square by 2 factorial plus z cube by 3 factorial plus etc. So what we will do is we will get e raised to z square is equal to, we will replace z by z square. So we will get a Taylor series expansion or series expansion of e raised to z square at z equal to 0. So 1 plus z square plus z raised to 4 by 2 factorial plus z raised to 6 by 3 factorial plus etc. And this is a series expansion of e raised to z square, and this must be unique by uniqueness of Taylor series. So similarly, in this problem, find Maclaurin series expansion of 1 by 1 minus z whole square. So we already we know that by Maclaurin series expansion of 1 minus 1, we know that Maclaurin series expansion of 1 by 1 minus z is equal to 1 plus z square plus z cube plus etc. So which implies, what will be the expansion of 1 minus z square? 1 by 1 minus z square is, we replace z by z square. So if it is z cube, then we will replace z by z cube. So 1 plus z square plus z raised to 4 plus z raised to 6 plus etc. This will be the Maclaurin series of uh, 1 by 1 minus z square. Now next problem is, we want to find out Taylor series expansion. So we know that Taylor series of f of z at z equal to z naught is of the form is of the form hmm, is of the form f of z is equal to sigma n equal to 0 to infinity f raised to n, that is f n the derivative at z naught divided by n factorial z minus z naught all power n. And one way you can do is, you can do uh, what we will do is, we can find f dash of z naught, f double dash of z naught, etc., and substitute in this formula. Or other ways, we will use Maclaurin series expansion of 1 by 1 minus z or 1 by 1 plus z to find the series expansion of 1 by 1 minus z at z naught equal to I. So we want, here z naught is equal to I. So we want the expansion in the form z minus I. So already we have 1 by 1 minus z. This can be written as 1 by, we want this thing. So 1 minus z plus I minus I. Okay. So this can be written as 1 by 1 minus I plus or minus z minus I. So you can write 1 by 1 minus I minus z minus I. Now this you can write, you can take 1 by, so what we will do is, I'm taking 1 minus I outside, 1 minus z minus I divided by 1 minus I. So this is equal to, therefore we can write 1 by 1 minus z in the form 1 by 1 minus I into 1 minus z minus I divided by 1 minus I. Now we already know that the expansion of 1 by 1 minus z is equal to 1 plus z square plus etc. Now therefore by replace by replacing z by what we will replace, z minus I divided by 1 minus I. We will get 1 by 1 minus z is equal to, I am taking 1 minus I into, so here we replace z minus, so 1 plus z minus I divided by 1 minus I plus z minus I divided by 1 minus I all square plus etc. So this will be the Taylor series. Now if you find this by using the direct method, then also we will get the same answer. So this is the Taylor series of 1 by 1 minus z at z naught is equal to I. So the important thing is we want the expansion in form of z minus